Hey y'all, I just wanted to wrap up my last video and summarize it just a little bit better because I think it was lacking just a tad. But for the light dependent reactions, I have summarized the steps here and I'm going to walk through them with you while I look at the picture from the last video of the light dependent reactions. So the first step is photolysis of H2O. So that means H2O is split into two protons or two hydrogen ions, oxygen, so there's that oxygen that's produced by photosynthesis, and electrons. So that is what is shown right here at the initial stage of the light dependent reaction. So right here we have photolysis. The protons go over here to do their job. We'll talk about that again in a little bit. And those electrons go to photosystem 2. Now, those electrons go into photosystem 2 so that they can gain energy from the sun. So a lot of times you'll hear the electrons are excited. That means that they were given energy somehow. In this case, they're given energy from the sun. Okay? So that's the whole purpose of the electrons traveling to photosystem 2. After the electrons go to photosystem 2, they give their energy as they pass through the electron transport chain. They give their energy to, or they transfer their energy, we can say, to create that proton gradient. So that's what you're seeing here. So the electrons, these guys right here, enter photosystem 2. They go through the electron transport chain. And while they're doing that, they give away that light energy in order to help make this proton gradient, meaning high concentration, low concentration. So, since the electrons gave away its energy in order to help with that proton gradient, as it passed through the electron transport chain, it goes to photosystem 1, where it now regains that energy. So the electrons end up here next. This is step number 4. It regains or is re-excited. It's given more energy. Why? Because the electrons are now going to travel through that enzyme that I pointed out yesterday, but I didn't name it. It's called reductase, but it travels through that enzyme, and those electrons go into this reaction. So those electrons go into the production of NADPH. And if you'll remember, NADPH is going to be used later in the Calvin cycle. Okay? Lastly, and this is kind of happening at the same time that these steps are happening, that proton gradient that was produced is going to make ATP. So remember, we had photolysis of H2O. Those electrons went through the electron transport chain, and I just explained all that. The hydrogen ions, or the protons, go toward creating this gradient, meaning high concentration to low concentration. The whole purpose of that is when these hydrogen ions build up on the thylakoid interior, on the inside of the thylakoid, they will end up flowing from high concentration to low concentration through this enzyme, which I haven't named yet, but this is ATP synthase. You know this guy. Flows through ATP synthase, which essentially powers ATP synthase and gives it the ability to take ADP and P and produce ATP. Okay. Now, in the next video, I'm going to explain how these two guys aid in the Calvin cycle and end up producing glucose. I do want to point out a couple things about the chemistry of biology. So you'll notice that we have, in the light dependent reactions, we have oxidation, which is the loss of electrons, and then we have reduction, which is the gain of electrons. So that was the whole purpose of me going over that oxidation and reduction, is kind of to link those ideas together. In addition, we can kind of think of electrons as energy, or maybe energy carriers. So those electrons here are going to gain energy, and then it'll give the energy into helping produce that proton gradient. then that electron is going to regain energy. Why does it regain energy? So that this process here can happen. So in the next video, I'm going to go over the Calvin cycle in relative detail, not super duper, but in a good amount of detail to help you guys understand.